Hi guys, today we're going to look at one-sided limits. We're going to look at limits from an equation, undefined denominators, and rationalizing. We got a lot of fun ahead of us here, so let's get started. The first thing, I know you just laughed, it's okay. The first thing we're doing is the one-sided limits. We looked at last time and said, okay, the major point of a limit is if it's approaching the value from the left and approaching that value from the right, and they approach the same value, then the limit exists. As we went through and then discussed, if it didn't approach the same value, the limit did not exist, which is good to know, but doesn't always help us. We want to know everything we can. So that's why they came up with right and left-handed limits. So you'll notice here, after the number, you'll see a positive or negative sign. If it is a positive, then it means from the right. And if it is from the left, it has a negative sign. And you're only concerned of that one direction. So here we go, 1, 2, 3. As I look from the right, it's approaching that value of 4. As I look from the left, this one also happens to be approaching the value of 4. Looking at 2, approaching, we can see this one right there from the right is approaching 1. From the left is approaching 1. Go. Now we're going to deal with 5. Now, up till now, if I had asked you at the limit 1, 2, 3, 4, 5, right here, you can see that jump. You would have said the limit as I approach 5 does not exist, which is true. I want to know more specifically, as I approach from the right, I can see it's approaching a value of 1. As I approach from the left, it's approaching 1, 2, 3, 4, 5, 6. So yes, the limit as I approach 5 does not exist. But as I approach from the right, it has a value of 1. As I approach from the left, has a value of 6. If I asked you the limit, not the limit, the value at 5, I would say 6 because that's the one that's filled in. Okay, hope that makes sense. Next, when you're given an equation, just take a screen capture of this. Don't feel you have to write it. Try to plug it in. We've done that already, that if it works, great. Sometimes the denominator is going to be the issue, so you'll look to factor that. And you know if I can factor something out, that means that there's a hole there. And that's now different because we can approach that value. You'll substitute in, look and see if you can find values. And remember, as we're practicing these, use the calculator to see what it looks like. No, on the major test, you probably won't have the calculator for this type of question. But as you're practicing, go ahead and see what's there. What's it look like? What are you up against? So as we look at these 3, I have the absolute value here. So I'm going to plug in -1 minus 3 is going to be the absolute value of -4 is 4. I'm done. Okay, here we go. The next one, 3 times a -3 plus 5 quantity squared. So -9 plus 5 is -4 squared, or 16. Lastly, we have the horizontal line of 5. So if you're looking at that, you would know, here's your graph. Doesn't matter which x value I've picked, the y value is always 5. I've been having such a good time. I promise you I'll let you do a try soon here. So in number 1, I'm looking at it, and I can see, all right, I could plug it in, right? You will try that one. The example I want to show you is example 2 right here. If I plug in the -3 right now, I can see that the denominator would become 0, and that is just never good for us. So I will go ahead and I will factor that. X, 2, and 3. X plus 3 down here. I'm going to cross out those x plus 3's. You now know there's a hole at -3. Rewrite the limit as x approaches -3 of x plus 2. Plug in that -3, and you come out with -1. So I'm going to leave you here, and you will try 3. 3 looks a little stressful as you go through it. And you're going to find out, even when you're factoring, things don't always work out what you want. And you're going to definitely try number 1. The last type we're going to try here is the rationalizing technique. You can see in number 1, as I look at that one, plugging in that 0, it's just not going to be good. So we're going to use the conjugate. Yep, that word came back. Conjugate means that take this term right here and change the sign. This will become positive. So I'm going to multiply by radical x plus 1 over radical x plus 1 plus 1. Because technically then I'm multiplying by 1, so I'm not changing the value. I will double distribute here, and I'm going to have radical x plus 1 times radical x plus 1, or radical x plus 1 quantity squared, minus radical x plus 1, that came from the inside term, plus radical x plus 1, that's the outside term, and lastly, negative 1. And then my denominator is x times radical x plus 1 plus 1. All right, so numerator, square root and squared cancel out. These two terms cancel out. So I am left with x plus 1 minus 1 over x times radical x plus 1 plus 1. That then simplifies to x over x times radical x plus 1 plus 1. These x's have now crossed out, and I now finally have a situation. The limit as not h, x approaches 0 of 1 over radical x plus 1 plus 1. So I'll plug that 0 in, and I will end up with a value of 1/2. Okay. So you will try number 2. Why I'm writing it backwards. Okay, very similar procedure. I'm going to now start with. So I'm going to do number 3 now. And I can see if I plug in the 9, we're going to have the same issue. So I'm going to multiply by the radical, or excuse me, by the conjugate. So I'll have 3 minus radical x over x minus 9 times 3 plus radical x over 3 plus radical x. So in the numerator, I will end up with 9 minus 3 radical x plus 3 radical x minus x squared underneath the radical, which is x. And then I'll have x minus 9 times 3 plus radical x. I'm going to go ahead and cross these two terms out. 9 minus x over 3 plus radical x times x minus 9. That's the old rule of difference of negative 1. And I'll have the limit as x approaches 9 of negative 1 over 3 plus radical x. Plug in the 9. And I'll get negative 1/6. So you will try number 4 and number 2. Lastly, we have the complex fractions, which you can again see create a problem very quickly when I have that denominator of x. So you're going to go through and multiply by the common denominator of the whole function. So I'm going to multiply each term by the 2 times 2 plus x. And remember, I'm doing that to every single term, so it's in the numerator and the denominator. It's not changing the value. So in the first one, I'll have the 2 minus, now the 2's cross out, and I'll have parentheses 2 plus x. Make sure that stays there. And then everything's going to hang out here in the bottom. So then 2 minus x over 2x times 2 plus x. That equals negative x, because my 2's canceled, over 2x times 2 plus x. Those x's cancel. I'm left with negative 1 over 2 times 2 plus x. And then we remember, oh my goodness, we were doing this wonderful math right here. So I have a limit of 2 times 2 plus x. Plug the 0 in, and you'll get negative 1/4. I'd like you to try example 2, and we will do example 3 next time in class. Have a great night.